Wake up. Is it possible to feed electric back into the grid? Press return. By the way, guys, what I'm researching right now is how I could use solar panel to feed electricity back into the grid. I think that's sick. You don't even need to buy batteries. You just shove some solar panels outside, and they just feed electric back into your house or back into the grid. If you shut off everything in the house and you're producing still AC, it will somehow go back into the grid. I'm curious how specifically that works. How do you set your frequency of your AC of your inverter homemade to match that of the grid? And does that turn your electric meter in reverse? I'm believing it is, but I still am not getting clear answers. My end goal, at least temporarily, to save money on batteries, which is the real cost of solar, would be to home make solar cells, install them on the roof of my house, connect them to our grid connection, and they will feed our house electricity so we don't have to use as much from the grid. But when they produce more electricity than the house is using, which is kind of unlikely but possible, it would feed it back into the grid. And I'm curious how all of that would work and how you connect it all and what's all the science behind it. And I want to make all this from discrete components of just junk TVs I find by the side of the road. And I want to make the solar panels using actual chemical processes homemade. I want to know how to make a solar cell, but I'm not researching that part right now. I'm just researching how specifically that works as far as feeding it back into the grid. My guess is your meter just turns in reverse, but that seems crazy to me, so I want to see how that's done. It's called a grid feed inverter that would do it, and so I'll probably end up researching how to make a grid feed inverter, but first I'm just researching the Google question, is it possible to feed electric back into the grid? Solar power connected to grid notes to save money. So basically, comma, your solar cells will produce DC electric and you connect that DC electric to an inverter which converts it to AC electric at 124 or so volts voltage. Press S. So that you are producing a higher voltage than the grid, and then you connect that inverter to your live and neutral lines coming to any room of the house, and it will also need to sync to the same press Y, press C, frequency as the grid through voltage divider sensors and a microcontroller to set the timing of the AC inverter switching. And it will actually pump electricity directly to the appliances of your neighbors, or to any appliance your house is using. And it can send it to both, just as you can connect a battery to more than one device. The confusing part is, how does it travel through the lines leading to your room, comma, over to the electric meter, comma, back out and into another room on another circuit, comma, and also back out into the 220 volt main house feed, and then all the way out to the main transformer leading to the house, which will then convert it back up to 10,000 volts or whatever, and then go over to the transformer of the neighbor, get converted back down, and then go back through their electric breaker box and then out to one of their rooms. And all of this starting from your bedroom! Exclamation mark, question mark. Supposedly, comma, when you do produce a higher voltage AC from your inverter, and this makes a voltage potential difference compared with the voltage trying to be drawn by a neighbor, comma, the neighbor will actually pull from your voltage inverter, exclamation mark. During all of this crazy transfer, comma, because energy passed through your meter in the opposite direction, comma, your meter will actually flow backwards and rewind itself, indicating your house used less power. Press semicolon. Your electric company will not even need knowing about any of this, and all they will see is whatever your meter reads out to them at the end of the month as your total consumption. Press semicolon. They do not even care that you caused the meter to flow in reverse and thereby lowered the amount you need to pay for electric that month, because it really doesn't impact them in any way, and they just look at the net usage of power from their end and charge you for it. Press semicolon. In fact, comma, the only interest they take in the matter is if you go out of your way to notify them of the amount that you fed back into the grid using your solar inverter and they comma in addition to the energy you fed to yourself report this quantity to the government along with other solar using customers of theirs who also feed the grid, and they take credit for going green. Open quote. Close quote. Vicariously through their customers who fed, press return, the grid on the solar company's behalf. And because this makes the solar company look environmentally responsible and in compliance with laws demanding a certain percentage of energy be from sustainable green energy sources, comma, they often are willing to give you a small monetary reward to thank you for your contribution to the grid needs, which lowers their burden to produce power for your neighborhood. And so, this is a form of a pat on the back and is mutually beneficial to you and to them. Press semicolon. Not all companies will do this, comma, however, comma, but it doesn't matter because whatever power you feed back into the grid takes away from the power you used from the grid before. So let's say you used 10 units of power that month, but fed in 2 units of power on sunny days throughout that month. The solar company would then charge you for 8 units of power used for 8. Since 10 minus 2 is 8. And they only see the net power used and have no record or awareness that you turned the meter backwards by reverse feeding power back into the grid. Nor do they care. Press semicolon. In fact, comma, the only time they might care is if your inverter failed to shut off its connection to the grid when the grid is shut off. So let's say lightning struck a utility pole and the pole fell and the grid shut off the power at the plant to prevent someone on the ground from getting electrocuted from the live wire sitting on the ground. If your inverter is still happily trying to pump, press L, AC, electric, into the grid, comma, then the grid would still be live with you as the source instead of the power company as the source. Press return. But the power company workers trying to fix the line were told on the phone that the line is dead, and here your inverter pumps power into the line making it no longer dead. Press hyphen. Press semicolon. This could then electrocute them and surprise them because they thought the line would be dead. And, in fact, it was still alive. Press V. Note, however, that this concern is really bullcrap, because no electrical worker is going to trust a line to be truly dead, regardless of whether it was supposedly shut off or not by the power company. There is always that chance that it could be switched on by mistake or something, and so the workers will surely be wearing protective gloves and clothing, and will not ever touch the electric lines with their bare skin, because they would never take that gamble with their life. So really, it doesn't even matter if your inverter stays switched onto the grid when the grid is shut down. But it is just good practice. It is far more likely that whatever power my solar panels produce will get eaten up by my air conditioner, space heater, any lights in our house, the central air of the house, any fans blowing in the house, any alarm clocks on in the house, the refrigerator, the LCD display on all microwaves, etc. But, and this is a big hypothetical, if I did have a big enough solar array, it is possible that on a very sunny day, I would produce more power than all of those devices combined consume. And any leftover power would then feed the neighbors. This would require, of course, as mentioned earlier, that the voltage of my inverter be higher than the grid voltage, leading to my 120 volt line of my room. And by it being a higher voltage, it will backfeed and be converted upward to whatever higher voltage is, and then transferred across and over, and then converted back down into the neighbor's house, and feeding their rooms and their appliances. And the only limit to how much power goes out to the neighbors or to any other appliance in our house is the discharge speed that my power source allows. So, in the case of a lead-acid battery, they are only rated for a certain discharge rate. And if you go above that, it will burn out the battery. And so, you would first convert up from 12 volts to 124 volts with a boost converter, and then you would use an H bridge to create AC, and you would use a voltage divider to read the voltage of the home's AC, and you would match that and sync with that. Press Y. Press C. So that your pulses into the live and neutral lines match the timing of when those lines are going in the correct direction. Because they push one moment and pull the next, becoming positive in one moment and negative in the next. And you need to become positive in the same moment and negative in the same moment when connected to those lines, so that you are doing the same thing at the same time, and thereby assisting the rest of the system correctly. So when the live line is positive, you want your live line connection to be positive and of a higher voltage, so say 124 volts, and this way anything connected to that positive live line in that moment, which happens to be all of your appliances and the utility company and all of the appliances of your neighbors your 124 volts will feed out and away from your inverter and over to devices that have a lower charge than 124 volts. And so, by virtue of being the highest voltage source around, comma, power will go out from your inverter and seek out a lower voltage thing to attach itself to, which will be the neighbor's appliances, comma, your home's appliances, comma, and the grid in general. And I guess this 124 volts will need to go out in large pulses of power in order to meet and then exceed the power draw of all of the appliances in the house. Press semicolon. But if it is tied to my room, comma, my room can only handle 10 amps. And so, it would have to be under 10 amps. So under 1200 watts going outbound. But if we tied to many circuits of the house, comma, press hyphen, say 7 of them, we would then get access to 70 amps. And if we pumped out the full 70 amps at 120 volts, that would be 7,000 watts. Which would more than meet the need of the house on a typical summer day, and would meet a good chunk of the need of the neighbor's house. And so, not only did our house suck up that 124 volts I was producing and satisfy its thirst from my solar source, comma, but also the neighbor's thirst was being partially satisfied by my solar source. And my solar source was exceeding all of the need we had from the grid. And so it was spilling the abundant overflow over to the neighbors. And when doing so, it turned our electric meter in reverse. Possibly taking away from the forward progress the electric meter traveled throughout the morning preceding this burst of sunshine hitting my panels, and throughout the evening prior to that day. And so, sending the meter all the way back to the status it was at the day before, and so making whatever power we used that night the preceding night be undone as if it never happened, making that power free, plus making all of the power used during that sunny day free. So it would not only save on energy consumed, but also undo or give back, but also undoing or give back power used on previous days. And all of this is huge cost savings without the need for a single battery! Exclamation mark. Nor does it require the knowledge or consent of any power company exclamation mark. No legal red tape involved whatsoever, and no oversight! Exclamation mark. Just rolling back that meter and feeding the house like a hero! Exclamation mark. The only reason then to even use a battery at all for a solar setup in a home would be to take the excess energy produced on a sunny day and use it the following evening. But I would counter, why bother to store it and use it on the following evening when you can simply use power from the grid on that evening, and then the next sunny day you would get free power all day while the sun is out, and all of the excess power that sun produces that you are not using will just flow out to the neighbors' houses, and turn your meter in reverse, thereby giving you free power the night before, and making the power the night before that you would have provided to yourself from battery from the previous day's sun redundant, press U. Since the grid power was free anyways, as long as you feed back that power the next day, turning your grid meter in reverse the next day. So basically, every night you use grid power, and every following day you feed back into the grid the power you used from the night before, while also making enough power during the day to feed all of your needs for that day. And so you get no electricity bill at all. And as far as the power company is concerned, you were never connected to the grid at all, despite the fact that you used power from the grid every single night, exclamation mark. They just can't charge you for that since you put it back the next day, and so nighttime power becomes more of a loan of power to you from the grid that you pay back the following day. And the idea of trying to pay for and maintain expensive batteries to use during the evenings becomes completely idiotic since the grid power evenings are loans anyways and are always available. And so the batteries have no function at all at night, since you could have just had a free loan of power during the night at no cost. So why bother to have batteries to feed you that power at night? Question mark. That is simply stupid. And to top it off, the batteries cost, say, $20,000, and have to be replaced every 7 or 8 years, exclamation mark. There goes any cost savings to you, or at least a huge chunk of the money you would be saving by going with solar, and it increases your upfront investment by a huge amount, exclamation mark. What an absolute idiot move, exclamation mark. You are so much better off just simply putting up some panels and an inverter and letting those panels feed you by day and using grid by night. And if you put up enough panels, letting those panels feed your neighbors as well during a sunny day, which would then reverse any power the grid sent into your house at night, exclamation mark. A typical household will have a 7 kilowatt solar panel setup, which will produce 34 kilowatt hours per day on a normal sunny day. Cost per kilowatt hour of electricity. Electric costs 10 cents per kilowatt hour. So that means it produces $3 of electric per day. Or $90 worth of electric per month. Average household electric bill per month. The average electric bill of a household per month is $110 per month. So a 7,000 kilowatt solar panel setup will save $90 of the $110, leaving a total electric bill of $30 per month! Exclamation mark. That is amazing, and it would require absolutely zero maintenance and negligible upfront costs, as the solar cells themselves would be homemade, as would the grid feed inverter, and no batteries would be required! Exclamation mark. So the total cost to install this solar setup would be around $200 and would save the household around $90 per month, or $1,000 per year, every year, with no further costs incurred after the initial installation. Note, however, that I believe our solar power consumption is about double the average household because of me and my high energy usage habits and all of my electronic devices. So I could probably save us closer to $200 per month and $2,400 per year with a 14 kilowatt solar panel setup! Exclamation mark. And all of this for the same low cost of around $200 in raw materials to set it up. Press return. Press exclamation mark. Stop listening. Press K. System is a system that produces at any given moment when the sun is maxed out comma 7,000 watts. Press hyphen, which is 120 times 10 a single circuit of a house times 7, roughly. So it would produce 7 full house circuits maxed out at once, exclamation mark. That is enough to power our entire house with everyone up and using power at the same time, and still have enough left over to chip in to the neighbor's power needs, exclamation mark. Holy crap, exclamation mark. And here I am proposing even doubling that, exclamation mark. This way, we would have 14 full circuits produced at maximum light, and this would help to make up for the fact that most days are not going to be that sunny, and when a day is super sunny, we can pay back several cloudy days worth of power that we loaned from the power company and several nights very quickly on a sunny day, exclamation mark. This gives us a real shot at just getting free or like $2 electric bills every month, exclamation mark. Note that, unlike the example I mentioned before, it would be more practical to tie the solar systems directly at the root lines leading to our breaker box, because those don't have circuit breakers on them, and they would feed our whole house seamlessly without the need to connect to tons of lines leading to various parts of the house, and instead just tying into the trunk line. Press L. And pumping in $230 volts or whatever the trunk line sends to the house, with a little bit higher than it would normally send us, so that by us being higher in voltage than the rest of the grid, comma, my inverter will go outbound more powerfully than the utility company, which will cause me to feed power back into the grid in reverse. As whoever has the highest potential is the one that sends power out from himself. Note also that the grid does not supply a steady 230 volts or whatever, as its voltage actually fluctuates with time. So our voltage divider circuit will need to tell us the grid's voltage, which could range from, say, 230 volts to 238 volts. And it would just add 5 to whatever voltage the grid is doing to ensure that we are higher than it. And in turn, we feed power back to it. The same way as wiring two batteries in parallel, and one being at 14 volts and the other at 12 volts, the 14 volt line would feed toward the 12 volt line in order to neutralize their voltages and reach an equilibrium. That is how our grid connected inverter works! Exclamation mark. Exclamation mark. Undo. Press exclamation mark. Note that having batteries for the house is still a good idea, but the only use for them is for power outages. They are never to be used just because it is nighttime. We would simply use grid power at night and then feed that power back into the grid and then some the following day, which would yield a net power consumption from the grid of below zero, making all of that nighttime power completely free press semicolon. The batteries then would only come into play for when the grid is down. And the sun is down. If the grid is down and the sun is up, comma, our house would still have full power! Exclamation mark. In fact, comma, the neighbors' houses would also have full power! LOL. LOL. Exclamation mark. although, comma, that would be capped at the amount of current we are able to produce at the voltage we are needing to produce at, which would mean that probably the closest appliances to our inverter would all work but appliances further and further away would eventually not be getting enough power as the power demand would be higher than the power we are putting out. Since now the entire neighborhood is trying to pull from our inverter as the utility company is shut down. Wake up. Note that grid tie inverters generally are not plagiarizing. These are my own personal notes before I begin building my own solar systems. Stop listening. I'm going to build it all myself. So basically you have to build a solar array. You have to connect that DC produced power to a boost converter to boost it up to 250 volts or whatever the voltage supply, the main supply trunk line to your house is. And then you have to use an H-bridge of 4 MOSFETs switching at the correct frequency to tap into the grid at the same switching frequency mode. So like there's 2 lines, positive and negative. So whenever their line's positive, you have to make yours positive. Whenever their positive line switch to negative, you switch yours to negative. So you have to switch at the same times. You also have to have a little higher voltage than they have. And if you do all of that, then your photovoltaic cells, will send the sun's power into the grid. And it will turn your electric meter in reverse. So basically, if you produce enough power to power all the rooms of your house, and 7 kilowatt hours, or 7,000 watt hours is the equivalent of 7 maxed out circuits in a typical home. So that's 7 rooms of your house blowing full blown, a microwave, a space heater, everything. And a house isn't going to use more than that. Most homes don't even have 7 rooms. So a 7,000 watt solar setup, which is a common size, would actually produce more than the house needs, and whatever is beyond what the house is currently using would feed into the neighbors' houses. And whatever feeds out to the neighbors, that turns your grid in reverse, or it turns your electric meter in reverse. And so, during the day, you pay for all of your electric with the sunlight, and whatever excess is left over feeds the neighbors, turning your electric meter in reverse. And it will turn in reverse so much that all the power you used from the grid the night before gets rolled back. So that was all free, it was a loan. Because the power company only cares about the net usage. So if you use 4 units and then put back 5, you have a negative usage. So your power's free. So as long as you're putting back into the grid more than you use from the grid, you get to use nighttime power for free. So you don't need batteries. This idea of having a huge power wall, like the Tesla power wall, is a joke. Batteries are a joke. You don't need batteries. You just use electric from the grid for free and then put it back the next day when it's sunny out. So you should never have batteries for a solar system setup. That's a huge waste of money. That's tens of thousands of dollars wasted. The only time the batteries would make sense is during a power outage. And for that you could just have a generator or just keep 1 or 2 extra batteries just to keep the refrigerator turned on or whatever. And during the day you'll have power anyways. So during a power outage, you're only going to be out of power at night. During the day you have your solar set up to give you full power again. Alright, I know how solar works. It took a year for the power company to install the tie-in. They are not going to slow your rinky-dink homemade job tied into their grid. No, you don't tell the solar company that you are tied into their grid. They know your house is tied into their grid, and they feed you power. What I would be doing is having a power source of higher voltage tied into my connection that feeds my house, and because it's a higher voltage than the grid, it would backfeed into the neighbors' houses, turning my meter in reverse. The solar company has the power company has no influence on this, no say in this, no knowledge of this. All they know is when they check on your meter, it registers no power or negative power was used. Or maybe a little bit of power was used. It just seems like you just don't live there. That's it. There is no calling the power company out. They don't get called out. Solar only works as long as half the people still have coal power. Yeah, if everybody had solar, there would be nobody that would draw power during the day. Everybody would just feed their own power. Nothing would be fed back to the grid because everyone's already supplying their own stuff. And so it wouldn't turn your meters back because there'd be nobody to give that power to. So if none of the neighbors were trying to draw and you have extra power, it goes nowhere. So at that point, batteries would be actually desirable because your nighttime power would no longer be free because you're not ever turning your electric meter in reverse during the day because nobody's using it. It would still save you all the power you produce during the day. All your power during the day would be free. But your nighttime power that you get from the grid wouldn't get paid back then by rolling it back by backfeeding into the grid because there would be nobody to backfeed to. But none of my neighbors have solar power. Not a single one. I've never even seen, in my life, I've never even seen a house with solar panels on it. Never in real life. So that's not a concern at all. But you're right. Maybe in like Australia, if everybody has solar panels in their house in a whole town, you would just need to become isolated. Just get batteries and have your panels provide for your house for free electric all day, which has a huge value. And then for free electric at night, you can either pay for the nighttime electric or use batteries to handle nighttime electric, or just don't use much power at night to keep the cost down. Try to use most of your power during the day. I'm already tied into the grid. I'm getting power from the grid as we speak. All I'm proposing is having a machine that instead of sucking power, blows it. All of our devices right now are sucking. I want the devices to blow. It will first blow to every device in our house that's sucking, feeding that, and then it will blow into the neighbors. So I'm proposing a blowback, which will turn the meter in reverse. That's genius. Daytime solar power would pump. Yes, I could do that. I could put a big reservoir of water on a roof, and then pump it up a pipe and into there, and then it drop down through a turbine, which would turn a generator connected to an alternator, which would produce power, which would then feed our power at night. So that would be basically a battery. So yeah, that's a way to do a low-cost battery. That's an excellent idea, Spectre Dave. I approve. I would not get arrested. That's a lie. If that was true, that it's so bad, then why can you go on Amazon and buy a grid tie inverter for $128? This is 1,000 watt. If I bought 7 of these, $700, I could pump all the energy into the grid I want. But I'm gonna make my own using scrap TVs. It's way easier, and I could produce it for total cost and parts of about like $50 compares to $700. So by 7 of those, it'd be $50. So like 1/12 the cost, like 95% off, just using cheap discrete components like power transistors from China, power MOSFETs. And I can do the same thing that those lousy grid inverters are doing. I'm making my own grid inverter. Spectre, I'm not even proposing you connect your inverter directly to the outdoor power lines on their utility poles. All you have to do is connect it. You can literally connect your inverters to the lines of a circuit in your house. I could connect my inverter to an electrical plug in my room, and it would pump electric into the grid from my room, from the outlet. You don't have to go outside and have them run lines to your inverter. Or you can connect it directly at your breaker box in your garage. You don't need to contact them or anything. Just connect it. It's that simple. You can just splice into the wires in your walls. And that's household electrical work. It wouldn't be the $128 Amazon one. That was only for 1,000 watts. I need to have at least 7 to 10 times that. So I would need to buy 10 of those. It'd be like over $1,300. And what I'm proposing would be to make the same thing for $50. The goal of this project is to prove that you can create a solar setup and have free electric for your home forever for under $200 budget, using all homemade inverters and homemade photocells. Under $200 you can have solar setup, all DIY, and get free power for the rest of your life. And you don't have to buy any batteries. Net metering. Wake up. Net metering is where the power company pays for any power injected back into the grid. This is not really accurate though, because really, you are simply putting back power you loaned from the grid, and they just measure out at the end of the month the total power you used in net. So let's say you used 10 units of power and put back 8 units of power. The power company would charge you for 2 units of power. They did not pay for anything. They just charged you for what you used beyond what you put back in. If you put back in more than you used, comma, they just charge you 0. They don't pay you for the surplus. Although it would be interesting to see if they would, but I doubt it. I told you it's not touching the grid. Technically, when I plug my computer power cable into my wall, stop listening. I am plugging a power cable into the grid. If I generate a device that I plug into my wall, I am plugging that device into the grid. And if that device, rather than drawing power from the grid and consuming it, sends power out to the grid, then I am backfeeding into the grid. And you do not need to be a licensed contractor to plug a device into your wall. You as a homeowner have the right to plug anything you want into your wall. And so I will be plugging in a device that connects to my solar panels, and I'll plug that into my wall. And I can plug that into various walls throughout my house. That'd be a low-tech way to do it. Or I could just splice into the lines leading to our breaker box out in the garage. Either way. I haven't gotten to making my own homemade solar cells yet. I'm going to start that research after I'm done figuring out how to make my own homemade power grid feed inverter. Which is a big chunk of the cost. Like I said, it'd be about $1,500 to make one of these inverters, or to buy one of these inverters in the power level I'd want. But I can just make one for under 50 bucks in materials, probably like 25, 30 bucks in materials tops. $30 in materials to make something that you would have to pay $1,500 for, that's a good deal. A lot of savings. Totally worth it. That's the cost of a cheap car. And instead I pay 30 bucks, the cost of a dinner with my wife. And I have enough money and savings to buy a car. You don't see that that is worth my time? All for a couple lazy afternoons of soldering together some electronics components and making a video series covering it. I would say that's a very good use of my time, and I get paid for the videos as well. Not to mention a huge learning experience, super fun. Why would I bother? Because unlike what people think, I am actually grateful to live here for free. And it would give me some nice ammunition to give my wife and my dad if they ever said, like, you know, you don't seem grateful enough living here, you ought to pay rent sometime, or something like that. I could be like, dude, I gave this home free electric, that's my rent. So it would be my way to give back, showing appreciative attitude, and let my dad stick that money he would have paid on electric right into his savings for retirement. So I'll look like a hero and be doing a fun project that will benefit my YouTube channel. And when I eventually take over the house one day, when my dad dies, I'll have free electric, which will be very important to me when I'm paying the bill. That'll be super important then. But for now, it would just be cool from like a helping out type of point of view. And the best part is, I can make it small. Just start out a simple small inverter that just is going to source, I don't know, 1/50th of the power production of our house today. So a home basically uses $110 a month in power, which is about $4 a day. We might be a little higher because of my high consumption, so let's say $5 a day. Well, even if I could save like 60 cents a day, that's almost a fifth of the power. That could bring his bill down like $40 a month. Throwing up one panel like the size of the roof of my car might do that. Might be 50 cents a day. I'm not sure. I haven't done the math yet on the square area, but I could just start with a single small panel and run the DC power coming from that down into the wall and into my inverter, plug that into my room socket, and boom. Just right here at my room, I could make a huge difference, a dent. 40, 50 cents a day right there, boom. And doesn't even feed power back into the grid. It'd feed it back into the grid of our home, but it wouldn't be enough power to fill the demands of the home and then start feeding the neighbors as well. But I could keep adding every year when I get time, little more cells, expanding our roof solar cell presence until eventually I have enough solar cells that it's feeding most of, if not more than, the total power we use during the day on a sunny day, and starts feeding back into the grid. And that's it. And the grid people wouldn't even care. They check wirelessly once in a while to see how much power you're using. Between checks, they might, wait a week? Wait a couple days between wireless checks? Or maybe even once a month, you said. If they check once a month, they wouldn't know how much power you fed into the grid. They would just think you used less power. They'd have no way to know that, because they don't, unless if they tracked it by minute, and on a sunny day they would see the meter rolling backwards. If they checked it at the end of the month, they would see the meter rolled forward by a lot. They wouldn't see the backwards rolling when the sun's out. It would just be a net effect. They'd just look at the meter at the end of the month. So because of their slow check rate, they wouldn't have any way to even know, nor would they care. And like I said, it's not tapping into the grid. It's not like I'm climbing their utility poles and installing something. This is all just happening. You can plug it into the wall outlet of your room. You don't need a qualified electrician to plug a device into the wall outlet of your room. So you're telling me it's illegal for me to plug in my desk lamp? Is it illegal for me to plug in my phone charger? No, then it's not illegal to plug in any other device. And if you're going to say, well, it's illegal to plug in a device you made, so you're telling me if I make a robot, that's illegal to plug in? Because I'm making the power supply for my robot and it's using the same technology. But no, I can plug in any electronic project I make as a DIY electronic enthusiast. I can plug that into my wall. And it just so happens my project's going to be pumping power into the wall instead of sucking it out. Well, then we just saved money as a household. Exactly. That could be a giveaway if they're seeing negative net usage for the month. But I don't think that would happen because of all the dark days and rainy days and cloudy days and blah blah blah. There's no way I'd have enough solar panels to feed the entire house for the month, night and day. So it would have to not only feed every day 30 days a month fully, but then it'd have to backfeed into the grid more than all the power used during cloudy days and nights, which is also highly unlikely. So the net usage would still be greater than zero. It wouldn't go negative. And so it would just seem like we stopped using as much power. That's all they would notice different. That instead of us using $200 in power a month, we're now using $20 or $30 in power per month. They would have no idea we're feeding back into the grid. They would think we just turned off lights more often and people aren't home as much. That's it. That's as far as it goes. As far as the solar panels on the roof, for all they know, it could be a non-grid tied solar system, which does exist. You can have a non-grid grid tied solar system, and whether or not you use a licensed electrical contractor to install that, they wouldn't know that either. You could have a friend of the family who's a licensed electrician, which we actually do have one, and he could have done it for free, pro bono, and that wouldn't even be recorded with the state or country. They don't know about that. They would have no way to know any of it. Now, I won't burn anything to the ground because I'll use fuses. All my electrical projects, the first thing I do is I put in fuses. So anytime there's a short circuit or something goes wrong, the whole thing shuts off. That's day one electronics right there. Every single device has a fuse. Holy crap! I am not used to someone saying something I came up with could work, especially if it's something outside the box and extraordinary. So, well, I normally feel like I just waste my breath, but for me to have convinced someone in my chat room that I'm right after all, this is a world first. I need to celebrate this moment. That someone just said, you know what, this just might work. That is awesome. My powers of persuasion must really be going through the roof. That's not true. It's designed for 110 upstream and downstream, or both. Because live lines are going downstream and neutral's going upstream, and every time it switches phase, neutral's going downstream, live's going upstream. They go from plus to minus. They pull back and forth. That's how AC works, back and forth. DC is just one way. AC keeps switching. It's alternating current back and forth. So the lines are designed to send upstream and downstream. That's what AC means, alternating, upstream, downstream. Each circuit of your house has a breaker for either 15 amps or 20 amps. No, if you're feeding into it, your inverter is going to supply every appliance plugged in on your circuit. It will supply that. Once all of those have been met, then it will then supply other circuits in the house. It'll backfeed up, go through the breaker in reverse, and start feeding other appliances. As long as that backfeed to other appliances not on your circuit is below 15 amps, it won't blow the breaker. But it would just blow the breaker as per normal in reverse. The breaker would work in reverse or forward because the breaker is not, it has no polarity. It would just switch if it detects a certain amount of amps passing through. So if my thing tried to produce more than 15 amps, the breaker would blow in the garage and I'd have to reset it. So there's really no fire hazard either as far as overdoing what the line for my circuit can handle. So I could just tie into actual plugs in the wall these grid feed inverters in multiple different rooms of the house. But as I said, the easiest way though would be just to connect it to the main trunk line in the garage leading to the circuit breaker. This way you don't have to worry about exceeding maximum amperages because that thing has pretty much no maximum. It's designed to feed a whole house. So anything I could throw at it from a residential size power photovoltaic cell solar system would not, I mean, it wouldn't melt a line, the main line leading to your house. That's a big thick line. So you'd be fine, whatever you want to throw at it. So I just was saying as an argument that the legality of this is literally the same as me plugging a device into the outlet of my wall in my room. Will I actually literally do that? I could. I could literally plug it into various circuits throughout the house in order to feed the house. But that's too limited in amps. You're right. It's only designed for 15 amps per circuit. So if I wanted to go way above that and do like 100 amps, I need it attached to 10 different circuits. Or just I could do a single attachment if I just attach to the trunk line at the breaker box. And you can do your own breaker box work. There are non-licensed electricians on YouTube that have connected to their breaker box and ran a new line to their garage to put a breaker box in their garage so they can connect an air compressor to work on cars and connect their welder in their garage and whatever, and they put a garage breaker box. The guys doing those videos are not licensed electricians, but you can pretty much do your own electrical work as a homeowner. You can't do electrical work for the public without a license, but you can do your own electrical work. People do it all the time. It's been going on forever. And that's why sometimes electricians get called out to older homes and they have to redo all the wiring because it's not up to code because a homeowner did it. Homeowners do their own electrical and plumbing all the time. If it is illegal, it's not really illegal. I mean, nobody can monitor that. Nobody can slap you on the wrist because it's your house. What you do in your house is pretty much private and irrelevant to anyone. If no one was using the power, no, what you're not thinking about is that my inverter will have a fixed power output based on its switching frequency and based upon pretty much just it's pulse width modulated power. So if you give it like 80% duty cycle, you can lower the amount of effective voltage passing through the MOSFETs. So basically, if you have it switched off half the time and on half the time, you can slow down the current flowing through it. So because you can do current limiting, you can make sure that the current passing into your circuit is lower than what would trigger the breaker and also lower than what the wire is rated for. So you don't have to have an unregulated solar system that's just going to pump as much power as it wants. And on a very sunny day in July, it would just burn up your line. You can actually throttle and have your microcontroller actually detect how much current's passing and limit it to a safe amount. So all that can be done, no problem. And like I said, that's why circuit breakers exist. They don't get welded. They just turn off as soon as they detect the current's too high. Worst came to worst, the breaker would blow while we're not home. It's totally safe. The breaker blows way before the electrical wires running in your walls are at any risk of melting. That's why they're there. It's a total safety thing. It's something you don't have to worry about. The breakers will do their job. But I'm just saying that you wouldn't even need that. Even if there was no breaker, it still wouldn't be risky if your system regulates the amount of current, which mine would. It's not tapping into the public grid. See, I think the confusion between us is coming where you're picturing me tapping lines outside of my house where those lines are no longer owned by the homeowner. So the utility company probably owns the lines all the way up until the point that they tie into your breaker box, and then it becomes your electrical lines from there forward. As long as I'm tapping at or near the breaker box, that's my own property, it's part of our home. If I go outside and tap into and splice into the utility lines outside of the house that are owned by the power company, that's where it's illegal. Does that make sense? So I can tap into our trunk line indoors right at the breaker box. I could even tap into the bus bar of the breaker box itself. Meaning the actual physical breaker box, I could be tapping in with screws into the box, where it then branches out to all the circuit breakers. I can tap in right there. I don't have to go outside on a ladder and chop the utility line in half with a root cutter or a bolt cutter and try to splice into it. Like, this is not anything like that. My home breaker box already is tied into the power grid. I'm not adding any new connection. I'm tapping directly into the breaker box itself. This is no different than me walking outside and screwing in a new breaker to install a new circuit for a new room in the house, or an additional circuit for the same room. People do that all the time. In fact, I have one right here. This is a circuit breaker right here, and I'm planning to install it and run it to my room. It's a 20 amp. We have a 15 amp. I want a little more amperage because sometimes my shop vac causes my stuff to trigger, and it's the only thing plugged into that whole outlet, that whole circuit. Just one vacuum is blowing the 15 amp. So this 20 amp will make the vacuum not do that. That's my plan. Now, me installing that is no different than me installing an inverter. The same way that snaps in, I could snap the inverter in. And that's my tie. I'm not talking about going outside and cutting into the main utility line running to the house. I'm not talking about touching any of that. I'm modifying our breaker box in our house, our property, as the homeowner. Are you allowed to install a new circuit breaker yourself? Of course. Are you allowed to flip the circuit breaker back on when you've blown it, or do you have to call an electrician out to flip the switch? Of course. People do this stuff all the time. People run electrical in their houses all the time. You're not allowed to do it commercially for other people for profit without a license. Then you'd be pretending to be a contractor. In fact, you're even legally allowed to install solar panels on roofs without any certification. There is no licensing program. You have to be a licensed electrician to install electrical stuff for customers. You have to be a licensed plumber to install electrical systems for customers. I'm not sure about HVAC. You might have to be a licensed HVAC guy. But there's no such thing as being a licensed solar panel installer. That does not exist. You can get certified federally, but there is no such thing as a licensed solar panel installer, dude. You don't have to be an electrician to install solar panels. Although technically, I guess you would need to hire an electrician to connect the solar panel wire to the breaker box. So you could set up everything and then have the electrician plug in a plug here and plug in a plug there. As a technicality. Pay the guy a service call. He's going to be out there in 5 minutes. You could do everything else, though, as the solar installer company. And I have some family members who are planning to start a solar company. But the point I was saying is that what you do in your home is not something anyone can see, or not anything you can get in trouble for. It's in your house. People do electrical jobs and plumbing jobs in their own homes all the time that is not up to code, and when they go to sell the house, the inspector flags it all and makes you fix it if the home buyer sends an inspector out, so that your house gets up to code. Or if you want to rent out the house, you have to have it inspected to make sure it's all up to code. So local governments know in advance that people do their own homemade DIY work in their homes, and that's why they send out inspectors. If they felt that a licensed contractor always did all the work, then inspectors wouldn't even be needed. But licensed contractors don't get involved when there are DIYers that do it themselves. No, you stop listening. You can't make your own. Stop listening. You can make your own power grid technically, but then the power company would need to start paying you if you produce more power than you use. And that would also mean probably an inspection, because they'd be like, what the hell is going on here? They're producing more power than our nuclear plant. Uh, which I could do, but they would find it very suspicious. Heck, I could run power lines underground to all the neighbors and stuff, and charge them half cost what they've been paying to the utility company, and they'd probably be down. I could just tunnel. Or I could even run wire through our grass. I'm not sure. There's probably laws about building your own utility poles. I don't know if I'd want to go through that. I'd probably just tunnel. But, yeah, just create a robotic mole, and it would dig holes underground, sending the wire through underneath the yards to all the neighbors. And then I'd just do backyard under the table deals, and I'd make a killing. But the question would be, how do I produce enough power to power the whole neighborhood? Well, I would have to create my own nuclear power plant. And we all saw how that went with that one guy that made his own nuclear plant in his shed, and he got cancer and died. What was his name? Nuclear Boy Scout, I think. Alright, he's definitely getting my subscription after that intro. That's true, he's not nearly as smart as me. I could easily make a nuclear power plant, and it would be totally safe. And it would be superior to all nuclear power plants ever made by mankind prior to then. I would completely revolutionize the field. What's Momo? Okay, notice that this thing is an aluminum heat sink facing downward. See the fins? So this is just a heat sink with two power MOSFETs on it. Now he's using a 50 hertz oscillator. I wouldn't do that. I would just use an Arduino to switch these. So he's doing the timing. He doesn't want to use any circuits. This is all analog. I would just use a digital circuit. I'd use an Arduino. No big deal. They cost $3. All my projects are based on Arduino. I don't need fancy oscillators. Plus, my inverter has to become in phase with the grid, and so his oscillator's timing would not match the timing of the grid. Even though it's 50 hertz, it wouldn't necessarily be within one degree of phase. In other words, when live is positive and neutral is negative, your live needs to be positive, neutral needs to be negative. When live turns negative and neutral turns positive, your live needs to be negative and your neutral needs to be positive. You need to match. Your timing needs to be in sync. Okay, his other problem is his inverter is based on a large transformer. That's a huge mistake. You should make an inverter that's transformerless. It would be a fraction of the weight, and it could be much more powerful and higher in speed, meaning carrying more current at a higher speed than the transformer would allow. Also, a transformer is made of galvanized, siliconized steel, which is a magnetic steel, and I wanted to learn how to make that. I still haven't figured that out. I would like to make my own steel like that, because then you can make your own motors and transformers and stuff, DIY. So I still am working on that. What I was thinking of doing is just melting down old transformers to get a vat of liquid siliconized steel, just melting it all into one, and then pressing it out into sheets. And so I can make it that way. But that requires steel melting, which is tough to pull off. So that would be hard. But we could totally do it. But anyways, what I was getting at is a transformer made of large amounts of steel is very heavy. The transformer shown in this picture probably weighs like 5 pounds. So his inverter is going to weigh at least like 5.5 pounds. The inverter I would make, which would do the same thing and be 100 times more powerful, would weigh like half a pound total. Stop listening. Here's the back of a switch. These are power N-channel MOSFETs. There's 2 capacitors. There's the transformer. That's a pretty big transformer. Wake up. How to make H-bridge inverter. I understand this completely. This resistor is the load. Having it in the center there I disagree with, but that's your AC load. This is the output. I would draw that like out here somewhere. I'd just say live and neutral. Yep, in pairs, got it. And you know what? Stop listening. This quote-unquote clock and frequency divider, that could just be replaced by Arduino. The Arduino is just going to connect directly to the 4 MOSFETs. It'll switch them on in pairs, opposing pairs, just create an alternating frequency where one line's plus, the other line's minus, and then the other line's minus, one line's plus. And it'll just keep flipping it back and forth at 60 hertz or 50 hertz. And it has to be in sync with your AC line of your house. Boom, done. This is so easy. Also, you need to monitor the voltage of the grid. So if the grid's 240 volts or 244 volts, it's going to vary it over time. You want to always be a few volts above the grid. You want to be higher than it. Because if you think of the grid as a battery, and if you think of your inverter as a battery, the battery with the higher voltage sends voltage to the battery with the lower voltage. And that's the only principle you need to know. So you want your voltage to be a little higher, so you'll send voltage their way. This is so simple, man. I totally know how to do this. I know how to do this in code. I know how to do this in wiring practice. I completely get this conceptually. Completely. And you know what? The same exact way H-bridge inverters work is also the same way H-bridge motor drivers work to turn a motor in forward and reverse. Same exact thing. An H-bridge of NPN power MOSFETs. NPN. Press semicolon. When the live line is positive, comma, the H-bridge needs to be positive on that line. And when the live line is negative, comma, the H-bridge needs to be negative on that line. And so we send our positive and negative flow to sync with the grid's positive and negative flow. And we also need to modify our voltage to be 3 or 4 volts higher than the grid at all times, so that power flows out of our inverter and into the grid. Press semicolon. This can be achieved with a regulated buck converter or boost converter, depending on if we are needing to raise or lower the DC coming from our solar panels. Press semicolon. Stop listening. If I'm successful, guys, my dad's electric bill is going to go from $180 a month to approximately like $20 a month or $10 a month, while still consuming the same amount of electric in our house, and for a total cost to install this solar system of under $200. So in a month and a half, the first 6 weeks after installing it, it will already have paid for itself in raw materials. There will be no batteries involved. You basically have sunlight power your house all day, and it also produces enough to more than power your house, so you also start powering the neighbors' houses. And whatever power it over-generated, causing it to power the neighbors' houses, turns your meter in reverse. And so it back rewinds the meter from whatever power you used the night before. So at night, when you're not producing solar power, you use power from the grid, not from batteries, because you don't need batteries if you're connected to a grid. And then the next day, you supply enough to power your house and the neighbors, thereby turning your meter backwards. And whenever your meter gets turned backwards, at the end of the month when the power company assesses your bill, they'll see that all the times you used power and then backed it up, used power, backed it up, will have a net of maybe 15 to 20 bucks at the end of the month. Whereas it would have been 200 bucks if you weren't reversing it all the time, as well as during the day powering your whole house off solar. So it's the perfect system. It uses the grid whenever the sun's not out, but then as soon as the sun comes out, it reverses that loan from the grid. So you really only loan power from the grid. You're interested in results? Well, I finished a project today, guys. If you want to see results. None of you were here when I was working on it. This table, do you guys notice a difference? Look how tall it is now. Look how tall this table got. Why is it so tall? Did I shrink or did the table grow? It's shoulder height now. The printer's lined up with my face. Remember it was way down here? I did some major work on it to make that happen. I put a can full of nails under this leg. And I put a can full of nails under this leg to raise the table. But then the back of the table used to be held up by books. You can see the indent on the mattress where the books were. There's a big hole there. Well, those books are gone. How is the back of the table held up? It only has 2 legs. That's not possible. That defies physics. What's going on here? The back of the it's only got 2 legs. What's going on? I'll tell you what's going on. I put toe straps up on the ceiling today. The back of the table is strapped to the ceiling. And it's tied in on the corners. I did that today. I had to find the studs in the ceiling and put long 3.5-inch screws into it. And then I put copper pipe straps and I bolted them into the ceiling, and then I hooked these tow ropes onto it, and then I cinched it until the table was level. So what's the point of raising the table and taking it off my bed? Now I can lay under it. Now 2 people can lay in this bed. And that means there's more room. This table is taking up half my bed. I wanted my bed back. So I fixed it. So you wanted results? That's results. That was a big project. I finished it today. I know, if I moved out, the electric bill would go down a lot. I agree. That was engineering. What do you mean you're not impressed? I did that all in one day. I had to put 4 screws in the ceiling. At least somebody said great job. I think that was a good solution, good problem solving. I was like, how the heck do you connect a rope to the ceiling? Well, I made several improvements. Instead of using rope, I used hooks that were already built onto my toe straps. I wasn't even going to use toe straps before. I solved it. I came up with the easiest way. And who the heck would think to use copper pipe straps for that? Originally, I was going to try to put screws in the ceiling and then try to like tie the rope to the screw, but it would come off. So then I thought, well, what if I put washers on the screw? And I was like, no, the rope would still probably pop off of that. And I was really struggling. And I thought, well, I could make a steel bracket and drill 2 holes and then put that through. And then that kind of led me to the idea of using a pipe strap. How is that overkill? This table was resting half on my bed and half off the bed. So it only had 2 legs on the ground. And the back of the table was pressing down on my mattress, which was possibly causing long-term damage to my mattress by all that weight just sitting there, creating a indentation in the mattress that will cause back problems. I'm hoping it will pop back out eventually. 2 months of having a 300-pound weight not move on the mattress is going to destroy the mattress in that area, creating a divot. It's not a love swing. Commercially available solar cells. Wake up. Commercially available solar cells are made from silicon and are either multicrystalline, meaning formed of many pieces of silicon with a grained structure at the microscopic level that are casted in molds after being melted down, or are made using a monocrystalline structure, which is much more challenging to produce, but makes them of higher quality at producing more power. Multicrystalline solar cells produce a maximum of about 22% efficiency. Monocrystalline solar cells produce a maximum of about 26% efficiency. Efficiency is maximized when light passes through the solar cells and bounces around many times within the solar cell's thickness until all of the light is absorbed, with a minimum amount of the light being reflected back into the atmosphere. You want as much light to enter the solar cells as possible and as little to leave the solar cells as possible. Press return. Alright guys, this is 8x5, this is 40 cells. 40 times 4 is 160 cells. Times 1, 2, 3, 4, 5, 6, 7, 8. 1500, 3000, 1500, 3000. About 6,000 cells are in this solar array. 6,000 cells, each cell is half a volt, or no, each cell is 0.16 watts times 6,000. That's 1,200 watts. I wanted a 1,400 watt. No, I wanted a 14,000 watt. So I would need 10 times that. So I would need 60,000 cells. And it's $1 a cell. $60,000? That can't be right. My math must have screwed up somewhere. What do you mean this dream about nothing? Can't you see I'm trying to make my own solar cells? I'm going to save a fortune. I already figured out how to make my own solar grid-tied inverter. And my whole solar system I can make, but I just need to know how to make the cells now. That's the only part I don't know. Guys, I think this is above my pay grade. If you're getting into, I think it's too deep even for me. You're talking about... I mean, unless if I buy the silica. I could buy silica, but would that be... Oh, it might be cheaper. I don't know. I'm going to put this off on my to-do list. Wake up. Press return. Paste it. Research. Making my own solar cells using purchased silicon in pure form, which we would then cast into solar cells. And we would also have to figure out how to do doping I am not interested in trying to convert sand into pure silicon and then making the cells from this. Press semicolon. However, buying pure silicon and then learning how to block cast it into ingots and then wire saw it into wafers and then P-type dope it on the backside and N-type dope it on the front side to create a P-N junction, and then applying an anti-reflection coating and then placing this onto a metal collector layer and then coating the whole thing in a resin within would all be something I would be interested in doing, which is still going quite deep. But not so deep that we are refining the ore from sand. I think I'm going to try to make the cells in the future. I think I will. I was this close to just calling it off until I had the idea, oh wait, I don't have to make my own silicon. I'll buy silicon in bulk, and then I'm perfectly happy to melt that down and then saw it into cells and then do the doping. I'm sure that's just a chemical process, and I'd buy those chemicals. So just like when I decided to make batteries and I'm going to buy the lithium compounds I want for the desired battery chemistry, I'm not going to try to buy the raw elements and form the compounds, because that's beyond the scope of what I'm willing to do to make a battery. The same thing applies here. I'm going to buy the pure elements required to cast and make the solar cell. I'm not going to get them from sand. Refining elements from the periodic table from raw sources in nature, such as extracting lithium from the sands of a desert, is beyond the scope of what I'm willing to do for making a lithium battery. I just have to choose my battles and see how deep I want to go. I don't want to go all the way to the point where I have to do a safari and try to get passports and stuff to try to gain access to deserts to try to get lithium. It's just, that's ridiculous to me. When I can just buy the lithium compounds for way cheaper than that. It all comes down to cutting costs anyways. So if I have to go to the point where I'm spending more money just to prove I can get it from raw materials, I'm looking to do it cheaper. It's not cheaper if I have to fly out to another country to access their deserts to get the raw materials, when I can already buy the compound fully made for way cheaper than buying the individual components or trying to get them from nature. So you have to be practical about it. I'm going to try to source pure silicon and make my own cells that way, but I have to do a cost analysis though, comparing that to just buying the cells. It might be that the cells at this point are cheaper, in which case making my own solar cells would be actually more expensive and I shouldn't do it. So that needs to play into this, and I think I'll add that to my notes. Wake up. Press semicolon. Note that we need to do a cost comparison of the materials involved in making my own cells using silicon and whatever doping materials and anti-reflective materials we need to apply versus just buying the cells. If the raw materials to make my own cells cost more than a fully made cell, abort the mission of creating my own cell because it is not saving money, and so it is pointless and stupid to waste the time. That's not true. It was a very productive day. Keep your filthy lies to yourself. I got done a lot of work, and the next thing on my to-do list was researching building my own solar system. It's something I wanted to do since the last power outage. I wanted to take steps to make it real, to actually have a tangible understanding of how it works, how you can feed power back to the grid, how the savings works, how the inversion works, how all of it works. I know it all now. I can do it all. Using scrap electronics, I can actually make all this stuff. And the only thing missing then to finalize my complete understanding of all things solar was, can I make my own cells? And it turns out I can, but I still need to do a cost-benefit analysis of the raw materials to make your own cells versus buying cells. So that's the final step, but I postponed that. I marked down in my to-do list that I need to do that, but I added it to the end of my to-do list, even below the MMO. So it's going to be many years before I revisit that. But it will come, and I will get a lot. I'll decide then. So there will be a return to that topic, but for now, I'm done for now. I'm satisfied. And I got to cross off my to-do list. Here was the specific to-do list item that I got to cross off today. It's very real, very tangible. Very real progress. Verify feasibility of connecting solar systems and window solar systems, because they have window-based solar panels now that look like a window, and window systems directly to our grid AC lines in order to feed electric back to the grid and turn our electric meter in reverse, rewinding it and cutting down on the electric bill, rather than using solar into a huge battery bank and then discharging that bank at night. And this will cut down on the cost of solar systems because you aren't actually using batteries at all. I was able to do that, and I was able to verify that that's exactly how it is, that you can actually reverse your meter by day for the solar or for the grid power you used at night in order to get your money back for the grid power. So you're not charged for that if you put it back. Whatever you take from the grid, as long as you put it back when it's sunny out, it's free. So you don't need batteries ever. You just use the grid at night or when it's cloudy, and then you feed it back in when the sun comes back out. So solar can make your energy totally free without the need for batteries. So all I need to do is install solar panels on the roof, do all the electronics, of which I'm a master electrical engineer, and then I don't need any batteries. So the total cost of the solar installation to make all future energy usage in this home be free, or like $10 a month, some trivial amount, will be approximately $50 for all the electronics, because it'll all be homemade, which bumps down the price from like $2,000 down to $50, because I can use just scrap electronics components. And then the solar cells, I still need to do more research, but it's looking like it's going to cost around $4,000. But I can buy the cells in small doses over time. So I could buy like $50 worth of solar cells a year. And once my dad sees me building up a solar array on the roof, he might say like, how much money do you need to finish this job or whatever, and he might be willing to pay for it because it's directly saving him money. He's the one that pays the electric bill. So I'm benefiting him directly, and he could just save even more money by funding the project. But he won't fund anything if it's all talk. He'll need to see me actually complete it, have it working, and me say, Dad, at this point, all I need to do is just add more parallel arrays. I've done all the electronics, everything's working, we're already saving money. All I need to do is bolt more cells up there. You've seen my proof of concept, you've seen it working. The electric cost per month has already come down. If you invest this much more, your projected savings to pay for that investment will be, in 6 months, it'll pay for itself. Then he'd do it in a second. He'd be an idiot not to. Or heck, I'll say, Dad, how about this? I'll install all the solar, and you measure back 6 months what you average per month paying to the electric company, and I want you to pay me those payments every month. I'll get all our electricity down to $10 a month. The $200 you're paying now, you have to pay to me in perpetuity until the day you die. So I'll take the $190 a month as just free income, and I will do the upfront investment. So I'll pay for all the solar, I'll install it all, I'll get our electric bill down to zero, but under the agreement that my dad has to then pay me in perpetuity the $200 a month he's paying to the electric company. That would be another deal where I'm investing and he doesn't change anything in his monthly bills, and then I reap all the benefits and I make a bunch of money. But that kind of sucks for my dad, but it also would punish him for not believing in me and not investing in my project to begin with, in which case he would have been getting all the savings, and now I'm getting all the savings as a kickback for doing my investment of time and money into getting all the systems set up. So either way could work, but the main thing is I'm going to put this into place. The roof's not going to leak. I'll just use silicone to seal it all off.